Hi there, and welcome to the second installation of our flipped classroom. Today we're going to be continuing our discussion on the unit of measurement. Yesterday we talked about polygons and angles and the different properties that existed with those. And today we're going to be talking about the perimeter and area of two-dimensional figures. First off, I want to show you the formula sheet that is actually provided for you from the EQAO company. It's two-sided. On the one side you have the two-dimensional shapes with the perimeter and area for several of your closed figures, and then on the back you have the formulas for surface area and volume of three-dimensional figures. So as you can see, the surface area and volume, the equations look a little bit more complicated, and that's just because it breaks it up into their different faces as opposed to just having one face with the 2D. So as I said before, you're going to be provided with your own copy of this formula sheet for you to keep. You can make notes on it and annotations for yourself. You also get a brand new one for your EQAO exam. You don't need to bring the old one. And for your final exam in this course, you will also be provided with formulas like these. You don't have to memorize them. Woohoo! So to start off, we've got the perimeter of a half moon shape. So perimeter is defined as the distance around a closed figure. So this closed figure is a half of a circle. So I've got the formula sheet. We've got two versions for the circumference or the perimeter of a circle. One is with respect to the diameter, the other is in respect to the radius. Since the piece of information that we're given is the radius, it makes more sense to use the second equation than the first. So the circumference of a circle will be denoted as 2 pi times r. However, since we only have half of the circle, we're going to then be dividing that by 2. Okay, so that will give us the distance halfway around the circle. So once I put my values there, I get 2 pi times the radius, which is 5.8. And then again, I'm going to be dividing that by 2. Since I've got 2 in the numerator and 2 in the denominator, it will cancel out and I will be just left with 5.8 times pi. You want to leave that calculation of pi till the very end. And again, please do use your pi button as opposed to just 3.14 on your calculator. So calculating that, I get 18.22 meters as the distance around half of the circle. However, if I'm looking at the perimeter of this entire shape, I also have to keep in mind that I've got the base of that semicircle as well. So there's 5.8 as the radius, and then another 5.8 for the other side, plus the 18.22 meters that I got from the half circle will give you my entire distance around this shape, which ends up being 29.82 meters in total. Next, we're going to look at a trapezoid. So I have the following trapezoid shown here, and I'm going to be finding the perimeter around the trapezoid. According to my formula sheet, the perimeter of a trapezoid would just add up all of the sides. So I'm going to start with the top there at 8.4, and then the next would be 10.2. However, those two sides, they are equal. You can see that they're equal by the ticks. However, the problem is I don't know what those sides are. It's a common mistake. You can see the height there to mistake that that's 6.5 for the outsides of the trapezoid. However, they are not. It's actually just the height of the trapezoid. So taking a look at that triangle shape on the edge there, I have 6.5 centimeters as the height, and I need to find out what that side length is. This little section, the base section, I'm going to have to figure out using algebra. So 10.2 centimeters is the entire base, and then I'm going to be subtracting the 8.4 centimeters. That will leave me with the two little winged sections on the outside. I'm going to divide that by 2 because there's one on each side, and it's going to be symmetrical since both sides are the same, and I get that side to be 0.9. Now I have a right angle triangle. To figure out what the slant height here is, I'm going to use Pythagorean theorem. So if you recall, Pythagorean theorem is a squared plus b squared equals c squared. So we're going to be finding out the square of that hypotenuse, squaring 6.5 and squaring 0.9. will give me 42.5 and 0.81. I can then add those together to give me 43.06, and then I'm going to have to square root it to figure out what the length of that trapezoid side is, which ends up being 6.56 centimeters. So now adding that to my perimeter, I've got the top, the bottom, and now the two sides all adding together to result in 31.72 centimeters in total for the perimeter of this shape. Okay, please be sure to be conscious of this issue where you have the hypotenuse and the height. Sometimes you're going to be asked to find the height, especially when you're dealing with parallelograms and things like that, and you're going to need the height to calculate, let's say, the area of it, but you're actually given the slant height. So there is a difference between the hypotenuse or the slant height versus the actual height. Just to make sure you're getting the correct information before you input it into your formula. It's a common mistake that happens. Our last example in the perimeter section has to do with a hotel that's remodeling its outside entrance area. So we've got a tile walkway here that's going to be surrounded by different colored tiles, and we need to calculate the perimeter of the walkway. So we have two different shapes to calculate here. One is this partial rectangle where we have the two lengths, but we only have one width. So if I add up those sides, I get 5.2 and 5.2, and then that 2.1. Then I'm going to have to calculate the circumference of this half circle. The one piece of information that you're not explicitly given is the radius or the diameter. Since it is the same length across as the bottom, that diameter is 2.1. So I'm going to use the formula of pi times d and then divide it by 2 as opposed to 2 pi r, and input my radius as 2.1, and then I can sum all of these values together. So I end up getting 12.5, and then this half circumference of that circle is 3.2987. Adding them all together, I get 15.8 meters in total. Also, as a quick reminder, please don't forget to write your units. You will lose marks for proper mathematical form if you don't have the units as well. Now moving on to area. Area is defined as the two-dimensional space that a closed figure covers. As an example, I'm going to be looking at this parallelogram here, and as you can see at the top I have from the formula sheet the formula for area of a parallelogram, which is simply base times height. So in this case, I am given the right information right off the bat. So I'm given that the base is 5.4, and I know that the height is 2.1, so I can just input those into the formula, and away we go. Things would be a little bit different if I actually had the side length, or one of those parallel sides if you were given. Again, you would have to use Pythagorean theorem in order to figure that out. So we end up getting 11.34 meters squared for the area of this parallelogram. One key thing to remember is with area, we are squaring units. These are squared units, so not only do you have to remember to put in the units, but you also have to remember to square them as well. As a final example, I want to look at this composite figure, which is a flower bed. We want to put soil all over it. So we need to find the area that needs to be covered in soil. So you do have three shapes, but I would separate out into two because you actually have a trapezoid. So find the area of the trapezoid, and then we'll find the area of the half circle, and then we'll add them together. Okay, it is possible for you to separate these out into a triangle. It's still a trapezoid and then a half circle, but it makes more sense to just do the trapezoid and then the circle. So taking a look at the trapezoid, the formula for my formula sheet is a plus b times the height divided by 2. A and b are the top and bottom lengths, sorry. Inputting my values, the top length is 4.7 and the bottom length is 9.4. I'm going to multiply that by the height that I'm given of 4.5 meters and divide by 2. Okay, simplifying this out, you end up getting 31.725 as the area of the trapezoid. Now the area of the circle, going back to my formula sheet, I see that the area of a circle is pi r squared, and I am going to have to make one note in the annotations here is that it was forgotten to divide that by 2. So in your calculations, you can see here that we have the area of the circle being 0.63, and when it was forgotten to be divided by 2, so you end up getting 9.8. Adding that to the 31.725, you end up with a total area of 41.54 meters square, as opposed to the 51 that you see on your screen. It's just a slight mistake. Okay, it's pretty straightforward, this unit, this part of the unit anyway. Homework will be done in class. You're going to be completing questions 1, 2, 3, and 4 on page 432 of your textbook, and I'll see you tomorrow.